All right, so now we need to put everything together. We practice adding and subtracting decimals. We practice multiplying and dividing decimals and taking special care to determine whether or not it's positive or negative. So we take special attention to the sign. So the next thing we want to do is work on solving problems. Now, these problems are going to require you to think critically and understand which operations the question is asking you to do. Now, remember, as we're talking about problem-solving decimals, really there's 4 operations that we're going to ask you to do: addition, subtraction, multiplication, and division. It's only 4 for these type of problems. So you've just got to determine which one you're working on. Now, for the purposes of these problems, I'm going to show you how to break them down into steps or stages. Just know you can use one expression to calculate the answer rather than just steps like I'm going to show you. And then finally, I'm going to show you how you might calculate the rate of change for these type of questions. So let's get started. I'm going to give you guys a problem here. The problem reads like this. On Sunday, the temperature at the Blood Reserve near Standoff, Alberta increased by 1.2 degrees Celsius per hour for 3.5 hours. Then it decreased by 0.9 degrees Celsius per hour for 1.5 hours. And this is a 2-part question. Number 1, what was the total decrease in temperature? And then number 2, what was the average rate of decrease in temperature? So those are the 2 parts of the problems that we're going to solve. So to do this, what I want to do is I want to start by calculating this in stages. So with this kind of problem, we've got sort of 2 stages. First off, the temperature decreased by 1.2 degrees Celsius per hour for 3.5 hours. That's sort of phase 1. Then it decreased, so decreased there, decreased by 0.9 degrees Celsius for 1.5 hours. So we want to know what the total decrease in temperature was. So I want to calculate this in stages. So let's do this. We're going to first talk about the first stage. So I'm going to write stage 1. This is the first part of it. Now, it went down 1.2 degrees Celsius per hour. So every hour the temperature dropped 1.2 degrees Celsius. Now, if it's dropping, I can represent that number by negative 1.2. So the temperature is going down 1.2 degrees Celsius. And I can represent the amount of time it took by 3.5 hours. So the question is, how much did the temperature drop over that 3.5 hours? Well, what I find really helpful here is to look at my units. So up top here, I have degrees Celsius, and on the bottom, I have hours. Now, if I were to multiply those 2 together, I would end up with hours and hours canceling out, all right? And I would be left with just degrees Celsius. It wants to know what was the total drop over the whole time. Well, in stage 1, I want to know the total temperature drop, not the temperature drop per hour. So those 2 cancel each other out. So I'm going to multiply those together. So it's going to look like this: negative 1.2 degrees Celsius per hour times 3.5 hours. Now, hours and hours cancel each other out. And so now all I have left to do is just calculate it. So on my calculator, I'm going to go negative 1.2 times 3.5. And that is going to give me a negative 4.2. So over the course of those 3 hours, our temperature dropped. Let's go back to the screen here. Our temperature dropped 4.2 degrees Celsius. Does that make sense so far? We're all on the same page there. So that's stage 1. So now let's look at stage 2. Now, in stage 2, it says that it then decreased by 0.9 degrees Celsius per hour for an hour and a half. So I can represent stage 2 by negative 0.9. Now, that's negative here because our temperature is dropping. Okay, as our temperature goes down, I'm going to represent that as a negative. So negative 0.9 degrees Celsius per hour for 1.5 hours. Now, again, I want to know the temperature change. So I'm just interested in degrees Celsius. So I'm going to multiply these two together, and I'm going to watch my hours and hours cancel each other out till I'm left with just degrees Celsius. So let's go ahead and do that. We've got negative 0.9 degrees Celsius per hour times 1.5 hours. Now we're going to watch our hours and hours cancel each other out. So essentially what we're doing is we're just going 0.9 degrees Celsius times 1.5. So let's do it on our calculator. Negative 0.9 degrees Celsius times 1.5 hours gives me a negative 1.35 degrees Celsius. Sorry, this one up here as well. Both of these, let's take my face off the screen. Both of these are in degrees Celsius. So we dropped 4.2 degrees Celsius, and then we dropped another 1.35. So the question says, what was the total decrease in temperature? So in order to do that, I'm going to take stage 1 and I'm going to take stage 2, and I am going to add them together. So my equation looks something like this. Let's just scroll up a little bit here so we can see. So I've got negative 4.2 degrees Celsius plus a negative 1.35 degrees Celsius. Now, if you want to make it clearer, you can put it in brackets. That way you can see that is a negative number there. So I'm going to go ahead, I'm going to plug that into my calculator, a negative 4.2 degrees Celsius plus a negative 1.35 degrees Celsius, and we get our answer of, let's get face out of the way, negative 5.55 degrees Celsius. So this here is the total our temperature drop. Now, on a word problem, I would expect that you would go through and you would rewrite your answer as words. So I would say the total decrease in temperature was negative 5.55 degrees, degrees Celsius, not percent. Let's rewrite that, degrees Celsius. And that would be the answer that I would leave on the bottom. This shows me that you understood the question that was being asked. So that's sort of one way to do it in 2 stages. I want to briefly show you what it would look like to do it the other way in just 1 step. So same question, all right? But this time, oh, you guys couldn't see me write anything there. That's too bad. Oh, well, I'll fix that. We're going to do this in just 1 expression. So 1 expression to represent the whole thing. So we can represent the total temperature decrease like this. 3.5 hours times a negative 1.2 degrees Celsius per hour, that's phase 1, plus 1.5 hours times negative 0.9 degrees Celsius per hour. All right, this whole expression allows me to do the problem in sort of 1 step. Now, to me, I always prefer to break it down. I want to understand what's happening at each point. However, for some of you, you'd rather do it this way. So let's go ahead and plug all of this into the calculator here. So we're going 3.5 times negative 1.2 plus 1.5 times negative 0.9. Just like that, if I punch this directly in, I'm going to get the exact same answer of negative 5.55. All right? Now, that's because your calculator is smart and it understands bed mass or ped mass or whatever it calls. It's going to do our multiplication first. So 1.5 times negative 0.9, 3.5 times negative 1.2. It's going to do those first, and then it's going to add them together. Your calculator is smart like that. You could also on your calculator lay it out this way. 3.5, you could put it in brackets just to make it clear for yourself. 3.5 times negative 1.2 plus, and so notice I closed off my brackets there, plus in brackets 1.5 times negative 0.9. Notice when I hit enter there, I get the exact same answer. So no matter how you lay it out, for me, sometimes I like to lay it out on my calculator so that it's just really clear for me what I'm asking the calculator to do. But your calculator is quite smart, so it's going to be able to do that. So that's the first part of the problem. We can do it in either steps, like we did in this one here, where we laid it out in sort of phase 1 and phase 2, or stage 1 and stage 2, or we can do it in one expression, and one expression to represent the whole thing. So there was one more part of that question. It asked us to calculate the rate of change. All right, the rate of change. So what does a rate of change means? Well, it's how much the temperature is changing over time. So to calculate that, we need to have the total. So our formula would sort of be the total, the temperature changed, and we need to divide it by the total time. Anytime we're talking about rate of change, we're talking about time. And so our total temperature change was negative 5.55 degrees Celsius, and the rate at which it's changing is going to be and we calculate the rate by calculating the total time. So our total time was 3.5 plus 1.5 hours. So that's going to give us 5 hours. So our formula ends up being, take my face out of the way, negative 5.55 divided by 5. And when we do that, we end up getting a negative 1.11. 1.11. So the average rate of decrease of temperature was 1.11 degrees Celsius per hour. Now, I want you to just remember, throughout the course of this problem, let's go back and look at the problem here, we had two rates of change, all right? We had this rate of change here, where we were talking about 1.2 degrees Celsius for that first segment, and then 0.9. So what we were doing was calculating the average, all right? So the average rate of change is 1.11 degrees Celsius per hour. Now, not all questions are going to look like this. The reality is that all these questions might look different, but the idea is the same. First, you need to identify which of the operations this problem is asking you to use, whether it's addition, subtraction, multiplication, or division. Once you've identified that, then you can lay it out however you want, whether you break it into chunks like I did, or you solve it all with one expression. So I've given you a bunch of problems to solve that all require decimals. Please, please, please don't hesitate to come ask me if you get stuck. Good luck.